All right. Hi, Pawan. Good to see you. Good afternoon to you as well, Samajit. How are you? All right. Okay, let me place this guy somewhere. Okay, here should be fine. Yeah. All right. Hello, Sugvinesh. Okay, it is so good to see all you guys uh, back. All right. That is good. That is good. So, can you let me know if my voice is all right? If the volume is fine? If you can hear me fine? Let me know if there is no issue with the sound and audio. Then should we get started? Yeah, I know. It's Samajit. Yep, I remember. All right. So today is the sixth lecture of kinematics, and today I'll be talking about projectile and also kinematics of circular motion. All right. Thank you for letting me know. So before we move ahead, let me introduce myself. I'm good. I'm good. All right. Thank you, guys. So let me introduce myself one more time for guys who still don't know me. All right. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. I have been teaching physics for IIT JEE for almost 8 years now, and I have taught at some of the most reputed institutes in India. And yeah, this is the first time that I'm teaching online. Before this, I've only taught offline, so this is a new experience for me as well. And I myself was JEE Rank 447 in IIT JEE, and I have already coached a lot of students to top ranks. But as I said, this is my first time teaching online, so I hope I can continue delivering the same way here also and help you guys to achieve your dream ranks. All right, so moving forward, let's also talk a little bit about the Unacademy subscription. So, since Unacademy has given me this wonderful opportunity, it has given all you guys also this wonderful opportunity, to bring us face to face. So, it is worth mentioning that you can get an Unacademy subscription and prepare for IIT JEE with the help of that. Uh, okay, thank you. So, what are the benefits that your Unacademy subscription comes with? So, first of all, you have live classes. Second, you get to interact with your educators on a regular basis. Then you have live polls and leaderboards. Then you have test series and analysis, and finally, you have live doubt clearing sessions. So, I know a lot of you guys are, I think, mostly are worried about your doubt clearing sessions. So, as a part of all the courses on Unacademy, doubt clearing sessions are a compulsory part. So after every 3 sessions, a fourth session has to be a live doubt clearing session. All right. So there is no teacher who can get away from that. So all right, I think that'll help you greatly. All these plus points, in fact, will give your JEE prep a huge boost. Okay, and then of course, on top of everything else, you are getting access to India's best educators with your Unacademy subscription. All right, so maybe not only for physics, you will get top educators for every subject. All right. In fact, you're often spoiled for choice. All right. So how do you get this subscription? So it's very easy. Follow these simple steps. Install the app. Once you've installed the app, go to the plus section. All right. Select your goal as IIT JEE and click on the get subscription button. All right. Now, if you look at the pricing, see the pricing of this subscription has been kept very modest. So I can definitely say that because I was teaching at one of the most premium institutes in India, and trust me, I know the pricing that was charged there. So this is nothing compared to that. Here, a 24-month subscription comes for just 1,500 rupees a month, which is very affordable. I think it's a wonderful thing that An Academy is trying to provide very affordable education to students at a very affordable pricing. All right. I don't know Hindi. How much I benefit from Unacademy Plus? I think. See, I think it's a good great thing for you that now Unacademy has started this English channel. So there will be courses on Unacademy Plus in English. That is the entire idea of hiring us. All right. Uh, All right, thank you so much. I think you're just being too kind, Samajit. I'm sure that's not the case. All right, Ankit. It's good to see you. Okay, Pavan. Okay, I don't know if I mentioned this. For the longest duration of my career, I think for half the time I've taught at Fiji. I've taught at all the institutes that you know. If you've heard of Akash, if you've heard of Pace, if you've heard of Vidya Mandir classes, every institute, every good institute that is there in Delhi, I've almost taught there. All right, so as I told you, this subscription for 24 months is already very affordable compared to any of the organizations that I was ever associated with. I mean, obviously, any offline coaching has to charge you more fees, definitely, and here you are getting your subscriptions at a very affordable pricing. Now you can make this even more affordable if you use my code RD Live. All right. So use this code to get your Unacademy subscriptions if you want to study from me, if you want to join my courses. So this will not only give you access to my courses, you can also join courses of other teachers. And using this code will give you an additional 10% off. All right. All right. So you can also join us on the Telegram app using this link so that you're not missing out on any lectures or sessions that are happening on the JEE English channel. And also my ID on Telegram is Rohit_Dixit. All right, that's my ID. So if you want to get in touch with me, if you want to maybe discuss some doubts, then you can catch me also on the Telegram app. Yes, why not? I will be talking about kinematics of circular motion. Yeah, I know. Circular motion can also have kinematics and dynamics, right? So today I'll be talking about kinematics of circular motion. All right. Okay, so without any delay, let's just get started with the topic. So we were discussing projectile motion the last time. Last time we discussed certain things. We discussed some formulae. It is a special case of 2D motion, where in x direction you have a non-accelerated motion, and in y direction you have a uniformly accelerated motion. All right, that is motion under gravity, and this can be seen as superposition of these two 1D motions. All right. So we had found the terms for, I think, velocity at any time, position of the projectile at any time, the maximum height of the entire projectile, the formula for the range, and so on. So we had found all these. So let's see if you remember that. Let's start with a practice problem. All right. So here in this problem, you've been told that a projectile is projected from ground at a height of 45 meters from ground. It has a velocity of 30 I cap plus 40 j cap. All right. You'll find the initial velocity, the time of flight, the maximum height, and the horizontal range. All right. So this was launched from ground. When it reaches a height of 45 meters, you realize that it has a velocity of 30 I cap plus 40 j cap at that time. You'd find the initial velocity, the time of flight, the maximum height, and the horizontal range of the projectile. So guys, get started with this. Just write trying in the chat so that I know that you are going at it. All right. So if I don't know how many of you attended this special session that I conducted on Friday. All right, there I talked about how to make the most of your online lectures. So part of that was that when I'm telling you to try a problem, definitely try a problem. See, why I tell you to try problems in the middle of the class is I want to see how much you're following me, and I want to take up any doubts that you might have. I mean, often you don't even realize, okay, if there was some part that you didn't understand. Okay, not really, not a very long problem. So it's okay. Only one practice problem, don't worry. Sometimes what happens is when you're listening to the theory, you think, okay, I'm understanding everything. But the moment you try solving a problem, then something weird happens. You're unable to solve. And then you're thinking, okay, what is it that stopping me from solving this problem? That is when you realize that what part of the theory you did not get. And that is why I think it's a wonderful thing. It's a must that you try all the problems that I asked you to during the class so that I can see whether you have followed the theory. You can realize whether you have followed the theory. And if there is some missing part, you can just get rid of it right away. All right. Because this is the best time. When you're learning things for the first time, should be the time when you should get rid of all your doubts. Next special class. Okay, I don't know. Probably day after tomorrow, or maybe after that in 2 to 3 days. If you're following me on the app, you will get the notification. So don't worry about it. If you're following me on the Unacademy app, you should get the notification. All right. So till the time you guys are trying this problem, let me just have some water. All right. So is Pawan the only one who's trying? Others should also try in case you aren't, and you should write trying in the chat so that I know that you guys are also trying. Uh, all right. That's great. I think everybody who wants to attend my classes should start following me there so that they're getting all the notifications about my classes. All right. Thanks so much. You're always so supportive and so kind. All right, Sukhvinesh. Good to know. Great. By the way, it's actually great to see the kind of support and love you guys show here. See, trust me, this is online teaching is an entirely new thing for me as well. So I have never taught online. I had my own reservations about teaching online. I used to think, okay, I don't know how that works. I don't know if the transfer of knowledge would be as effective as in an offline setup because I'm so used to that. I'm so used to looking at my students, all right, sitting right in front of me. So yeah, of course, that has its benefits because obviously when I'm having a discussion, I can point people out. I can talk to them directly, face to face. I can see them. We can have a wonderful two-way interaction. So I was a little skeptical to start with about the online bit. Because I used to feel okay, maybe just because of the communication gap, the transfer of knowledge probably would not be as effective. But and I also didn't know that how the students are going to respond. All right, how they're going to take the classes. I don't know because the kind of batches that I usually take, we have very serious students who are trying very hard. So if a student is hardworking, trust me, the teacher's job gets easier. All right. Oh, thank you so much. That's wonderful. That's a great thing. If so, all right. So yeah, trust me. When I was teaching at those great institutes, I mean, half my job was easier because all the students were so hardworking. Trust me, a teacher's job becomes very easy if your student is good. So I wasn't even sure if I don't know if online people will like my teaching because I don't know. I obviously coming from an offline setup, I do a lot of serious teaching. Okay, a lot of tough problem solving, a lot of intense discussion of theory, a lot of intense problem trying. So I wasn't really sure whether online students are willing to take that kind of discussion, that kind of pressure. But good to see that some of you are here, ready to put in the hard work, and ready to take that intensity. Or please let me know whenever you guys are getting your answers because I don't want to waste too much time also on one problem. Okay, so Pawan says initial velocity 60. Okay, I really don't remember. What? Maybe. Could it be? Maybe. We'll have to see. Okay, how about the others? Are others getting any answers? That is not a problem. Nobody is good from the very starting. But if you put hard work, if you have good guidance, then yes, you will definitely get good. All right. So don't worry. So keep working hard. Keep attending all my lectures. I will try and give you or let you know all that I know. And if you can follow that, everything that I'm telling you, and if you keep working hard on your end, trust me, you will be very good at physics. Because I am quite good at physics. Okay. So initial velocity 40. No, no, no. Initial velocity cannot be 40. That is, no, that cannot be the case. Initial velocity has to be greater than 50, by the way. Hi, Vineet, how are you? Alright, so why don't we start solving this? Because you guys seem to be taking a lot of time, which I did not expect. Okay, time of flight 12. So let's just write down Pawan's answers. No, 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 no. No, see, let me tell you, Samajit, that this is the velocity after some time, at some height. Now, if you remember, what happens to velocities? Or what happens to the speeds? The speed is the highest here and the highest here. As you go up, the y speed is constantly decreasing, x is remaining the same. So the speed will always be smaller at any other height, right? So the speed is always highest at the start and at the end. It is the minimum here. So the speed is going on decreasing from here to here and it will start increasing from here to here. Alright. So yes, if at some height this was your speed, this is your velocity. What is your speed? Mod of v vector, that is 50. Right. If at some height you have a speed of 50, then starting speed has to be greater than 50. Yes. Okay, maximum height 180. Okay. Okay. Pawan is getting a lot of answers. So let's see if he's getting the right answers. Alright, so what have I been told? I've been told that it was projected from somewhere here and then at a height of some 45 meters. The velocity is like this and v vector is given as 30 I cap plus 40 j cap. Alright, so what I know is when y equals 45, Vy equals 40. Alright, now I can find Uy. Right? How do I find Uy? I can use the fact that in y direction, the motion is of uniform acceleration, right? So I can use the fact Vy square minus Uy square equals 2 into acceleration being minus 10 into 45. Alright, I hope you guys realize what I'm doing here. In y direction, oh yeah. I mean, there is some change in weather. No. Given velocity is not initial. You have to read your question very properly. Alright, of course. Thank you for asking, Vineet. There has been a slight change in weather here. A lot of rain. So yeah, the change in weather always affects me. Alright. So what was I saying? Yeah, this is for the y direction. In the y direction, okay, this is what is happening. It started with some uy, and then at some point here, we know the vy. So that is why I'm using the equation vy square minus uy square equals 2 times ay. This is ay. Okay, this is minus y because the acceleration due to gravity is downward. So I'm taking the directions as upward direction positive, downward direction negative. All right. And my displacement is positive. Why? Because it has gone up, okay, by 45. So from here I can say that 1600 minus uy square equals, okay, so this will be 9900. So let's see what am I getting. Uy is, oh, there is a minus sign also. So uy is only 50. So Uy is 50. Okay, I hope you guys followed till here. Uy is 50. How about Ux? Now x velocity never changes. Alright, x velocity never changes. So if Vx is 30, so Ux will also be 30. Alright. So and I can say similarly, since Vx is 30 meter per second, it will be equal to Ux also. Because the x velocity never changes. So now I know u vector. Therefore, what is my u vector? Initial velocity vector. Initial velocity vector becomes 30 I cap plus 50 j cap. Alright. So what is my u going to be? So initial speed is root of 900 plus 2500. So I can say 10 root 34. That is my answer, Pawan. Unfortunately, you had it wrong. Alright. I hope you guys followed this. Okay, this will be close to 60, by the way. I think Pawan had given me an answer which was 60, but this is not exactly 60, but yeah, it will be close to 60 because root 34 is almost 6. Okay, so let me know if you guys followed this. Because v cos theta is, yes, absolutely, absolutely. It is always u cos theta, it never changes, the x velocity. That is right. That is absolutely correct. Alright, so let me know if everybody followed this. Yeah, that seems like the case. If of course your first answer is wrong, then maybe all your answers are wrong. So now you can say everything. You can say the time of flight, right? Time of flight was very easy now. Since you have uy, you know time of flight is 2 uy over g. So that'll be 2 times 50 over 10. So time of flight is 10 seconds. Alright, maximum height obviously is uy square over 2g. So maximum height becomes 2500 over 20. So that is 125 meters. So maximum height is 125 meters. Time of flight is 10 seconds. Range is very, very easy. You know the time. Time is 10 seconds. You know ux, which is 30. So range would be the x displacement. The x displacement would be x velocity into time. So let me write the answer for that also. Similarly, r would be 10 times 30, which is 300 meters. Alright, so these are your answers. Time of flight is 10 seconds. Range is 300 meters. Maximum height is 125 meters. And the initial velocity is 10 root 34 meter per second. Alright. So did you follow this? All you need to do is find the initial velocity vector. If you find the initial velocity vector, you know ux, you know uy, then finding everything is very easy. Time of flight would be 2 uy over g. Maximum height would be uy square over 2g. How is velocity 40? How y velocity 40? Which velocity is 40? Are you referring to here? Why is Vy 40? Vy is 40 because I was told that the velocity vector is this. Oh, okay. Okay, let me take your problems one by one. So what was I told? I was told that the velocity at a height of 45 meters from ground, the velocity is I cap 30 I cap plus 40 j cap. So here I can see at this height my x velocity is 30 and my y velocity is 40. Okay, here v vector is this, so this component is 30 and this component is 40. So this is vy, this is vx. Alright, because it has been given to me like that. Okay, Sukhvinesh. Because the velocity was given to me as 30 I cap plus 40 j cap. That is why here I am writing Vy as 40. Okay, no problem. Okay, Vinit. So as far as range is concerned, so what was range? If you remember, I told you yesterday, range is nothing but ux times t. Range is the x displacement. You know, the projectile travels for time capital T. In the entire duration, its x velocity is constant, which is ux. So for constant velocity, what is the displacement? V times t, right? So that is why range is ux times t. You knew ux. Where is it? Yeah, this was the initial velocity vector. Ux was 30, right? Ux was 30. Time of flight was 10. So the projectile is traveling for 10 seconds, and during the entire 10 seconds, its x velocity always remains 330. That is why the range is 30 times 10. Alright, Vineet, I hope that is clear. R, how I got my R. Please let me know fast. Okay, I don't think there should be too much doubt here left now. Things are pretty simple only. Alright, great. Now, this was one expression that we were about to derive in the last class. So, equation of trajectory. So, what is the equation of trajectory? Now, equation of trajectory is the equation of this path that the projectile is tracing in the entire duration. So, equation of trajectory is essentially the relation between the x and y coordinates. So, think of it like this. If I consider this as the origin, consider that I am taking this as the origin, and at this point I am taking its position coordinates as some x comma y. Now the relation between x comma y, if I assume a coordinate system like this, where this is y axis, this is x axis, and this is the origin, then the equation of this curve that the projectile followed is called the equation of trajectory. Alright, equation of trajectory is nothing but the equation of the path followed by the projectile. So let's see how we can find that. So let us assume that after t it reaches some point here. So at t equals 0 it is here. At some t equals t it is here. So this is t equals some t. So what I can say about this? Let's talk about the x coordinate. How can I find the x coordinate? X would be ux times t. Alright, because for the entire duration of t, it is moving with a constant speed. Okay, so I can write x equals u cos theta times t. Alright, so that is my first equation. How about y? I think it's relation between x and y independent of time. Yes. It is the expression of, it's the geometrical equation for the path. You are right. So I can say x is this. Also I can say, how about y? In y I know it is vertical motion under gravity. Okay, so I can apply the equation uyt minus half gt square. Now remember, every time I'm using minus sign with the g, because I am taking this convention that this is positive, so this side would become negative and this side would become negative. Alright, that is why g is always being taken as negative. Alright, so once you know this, now what you need to do is, the idea was to find a relationship between x and y. How can I do that? I have both of them in terms of t. So I can say that from equation number 1, I can say t equals x over u cos theta. Alright, now let's just substitute this value. Just substitute this value into this. Therefore, what do we have? We have y equals uy. Uy is u sine theta into x over u cos theta. Alright, minus 1 by 2 g times x square over u square cos square theta. So here you get cancelled, and what you're getting your equation as is y equals x tan theta minus gx square over 2 times u square cos square theta. This is the equation of trajectory. Alright, so I hope you guys realize how we got that equation. Please let me know if there is any step that you didn't follow. It's a very simple thing. I found x in terms of t, I found y in terms of t, substituted and removed t from the equations, and hence I got a relation between x and y. Now, obviously, you will see that what is the form of this? The form of this is y equals ax minus bx square. So this is a parabola which is upside down, which you can see here. All right. I hope you can see that. Okay. So if everybody followed this, let me know. Then we will move forward. Okay, this is one of the biggest expressions that you will encounter in projectile, and obviously it's because of that it's going to be the toughest to remember. Even I don't remember this very much. So what we can do is however we can represent it in a slightly different form. All right. So let's see a slightly different form of this. Okay. That is slightly easier to remember. Okay. Let's see. Okay. So what we can do is, all right. Thank you guys. For a moment, I thought all you guys had gone off to sleep and I was just talking to my laptop again. Alright, so I can rewrite this as x tan theta minus g x square. Now, what I'll do is that I will multiply and divide the expression with the sine theta. So let us do that. Multiply it with sine theta divided by sine theta. Alright, let's see what we are getting then. So I am getting y equals x tan theta minus g x square. So 1 cos and sine I can write as tan theta. And then I have 2 times u square sine theta cos theta here. Alright, so what I'm going to do is I'm again going to rewrite that slightly, and I will say that this is y equals x tan theta. Let's just take it common. So when I take x tan theta common, what am I left with? I'm left with 1 minus x over u square sine 2 theta times g. Now you will realize that this entire thing that you see here, this thing, this is 1 over r. Okay, I hope you remember your expressions for r. The range was u square sine 2 theta over g. Okay, so now I'll substitute this in terms of r. So I will get a slightly shorter form of the equation, which is still manageable, which I also remember. So trust me, I try to remember as little as possible. I don't like memorizing things. I think, my brain does not need to remember unnecessary things, only important things. Alright, there are a lot of things to remember in any case. So this is the form that we have. This is another form of the equation of trajectory. Alright, so this is also what you can use. Y equals x tan theta 1 minus x over r. So slightly easier form. It's the same equation, just that this should be easier to remember. Okay, so when you are remembering, you can use this form. Y equals x tan theta times 1 minus x over r. Alright, so maybe I can write it one more time. Y equals Maybe I can write it slightly bigger. X tan theta times 1 minus x over r. Alright, please remember this result. So you need to remember this. Alright, so why don't we move forward then? Next, we'll talk about radius of curvature at any point of the trajectory. Now, what is radius of curvature? So, radius of curvature of any curve is defined as, suppose you have any curve. You have a curve like this. Then radius of curvature at this point. What you do is you take any point here, or you have to take the radius of curvature here. Let's use a different pen. So let's say you wanted to measure the radius of curvature here. What does that mean is, radius of curvature is essentially a measure of how sharp the curve is turning at any point. Okay, if the radius of curvature is smaller, then the turning is not that sharp. Sorry, it is the other way around. If the radius of curvature is large, then the graph doesn't turn that sharply. For instance, a straight line would have a radius of curvature infinite. What do I mean by that? Let me show you. If I wanted to measure the radius of curvature at this point, what I do is I take a very small portion of this. Alright. Now, I imagine this small portion to be a part of some circle. Every small curve can be taken as a part of some circle. So let's say that this small portion in blue was a part of a circle like this. Alright. So radius of curvature is nothing but the radius of this circle. This is your radius of curvature R. Alright, so in case you needed to find the radius of curvature here, let's say here. Let's say here you wanted to find the radius of curvature and a small portion here. Then what you do is you draw a circle. And the radius of this circle would be called the radius of curvature over here. Alright, I hope you can see what radius of curvature is. So radius of curvature is nothing but the radius of a circle of which any part of the curve can be taken, any portion of the curve can be considered a part of. Every small portion of any curve can be considered a part of a circle, and you can say that all these different parts of circles were cut and joined together to form this curve. So radii of, or the radius of the circle of which this is a part of, would be the radius of curvature of this part. Similarly, the radius of the circle of which this part was a part of is called the radius of curvature of this part. So every part may have a different radius of curvature. Of course, in the easiest example of a circle, the radius of curvature of all the portions is exactly the identical. Alright, if the part is straight line, its respective circle would be infinitely big. Absolutely. That is what I was trying to say. If your graph is a straight line. Now, when you try to make a circle, it will be a circle of, it can be considered as a circle of infinite radius. So here, the radius of curvature R would be equal to infinity. Okay. Yes, so every curve can be considered to be made up of parts of small circles and different size circles. Alright, so that is what I'm trying to find out. So let us say that I want to know the radius of curvature at point P. The aim is to know the radius of curvature at point P. So, okay, so there is one mathematical thing that you can do. Okay, maybe you can ask your maths teacher for the proof of that. Okay, some of your books will also tell you this. So the radius of curvature at any point, suppose you had to find the radius of curvature at point P. So the radius of curvature at point P would be 1 plus dy by dx whole to the power 2 by 3 over d2y by dx2. So that is one way of finding the radius of curvature. If you know the equation of a graph, then this is how you find the value of r. If you wanted to find the value of r at p, you substitute the value of dy by dx at p, you find the value of d2y by dx2 at p, substitute them here, and that is how you find the radius of curvature. I'm not going to show you the proof of this. Okay, you can ask your math teachers. Oh, straight lines can make a circle. Yes, yes. Any straight line can be considered a circle of infinite radius. Alright, I hope you realize that, Vineet. A straight line is nothing but a circle of infinite radius. So, this was one way of finding the radius curvature. You already knew your equation of trajectory. Alright, from here you can find the dy by dx, you can find the d2y by dx2, substitute them here. But we are studying physics. We don't want to involve very complicated maths. So we will get rid of this. Alright. You can prove this also. This is a part of your maths syllabus. You can prove this in math. What we do is that we will find a smarter way, a way with which I can use my physics knowledge. Why? See. Let me tell you. Why is the thing turning, and that is why I wanted to take up the circular motion. I hope you guys know that every circular motion, in every circular motion, why does the velocity vector turn? So velocity vector is like this here, like this here, like this here. So you will see that the velocity vector is constantly turning. So suppose here it will be like this. So why is it turning? It is turning because of some force which acts here. And we call this force a centripetal force. Alright. iPad में कौन सा app? Okay, this is an app called. Okay, I'm not supposed to take names. Why should I just promote them? This is a good app. Anyhow. So I don't know if you guys really know this, that for every circular motion, the velocity vector is turning, everything is moving in a circle because there is a force which is directed towards the center. That force is called centripetal force. Alright, so it is the centripetal force that is turning the velocity vector, and that is why it is moving in a curve. Alright, I think I told you earlier also that when you have acceleration, then if you have a velocity like this, and if you have an acceleration like this, then the component of the acceleration which is along the length, this changes speed or the magnitude of velocity. This guy changes direction. I think I had mentioned this. Alright. Not sure what you mean, Aryan Kapoor. Yeah, that is what I'm saying. I wanted to discuss this after. I can discuss this after circular motion also. I have circular motion which is supposed to be discussed today. But since I'm discussing all the expressions involved, this is a very simple, small expression. So let me just consider this right here. So I will show you that this happens. I will show you that the centripetal force, there is a force which is called centripetal force. Okay, that is the one that is responsible for turning your velocity vector, and that is why anything will move in curves. If you don't have this acceleration, then it will just move in a straight line. If you have this acceleration, then the velocity vector will start turning and your particles move in curves. So here, the simple way of finding the radius of curvature is, you find the external force mg, you find it has two components, one like this and one like this. Alright, so this component of mg would slow the speed of the projectile. This component of mg would be changing its direction. Okay, so let's see what that component of mg is. So this I know would be alpha as well. Alright. Generally as a rule, you shouldn't take any names. Okay. Alright, so this component of mg becomes mg sine cos alpha. So let's see. So force perpendicular to V equals mg cos of alpha. So obviously you already studied Newton's laws in class 9. So though we haven't discussed that, I can say A perpendicular to V vector. What will that be? That will be g cos alpha. Alright, so when a perpendicular acceleration is there, then the body tends to move in a circle such that, let me tell you this, we will see the proof of this, such that A perpendicular, also let me tell you, I'm not showing the proof, A perpendicular is V square over R. Okay, I will show you this later. For those of you who already know this, very good. That if you apply a perpendicular acceleration, the perpendicular acceleration causes a guy moving with speed to move in a circle of radius small r. Okay, so A perpendicular makes a particle moving with V to rotate in a circle of radius r instantaneously. Okay, so this is only instantaneous. All right. So let's just substitute this. When we substitute this, A perpendicular I know is g cos alpha. So what I get is g cos alpha equals V square over R, or I can say that R is equal to V square over g cos alpha. Please remember this result. This is very important as far as your mains is concerned. Let me tell you, IIT JEE Mains has asked this one question twice. What is the question? Let me ask you. Okay, so try this question. Find the radius of curvature of a projectile at the topmost point of its trajectory. Alright, so let me give you this. Let me give you this practice problem. Let's just write it here. Find the radius of curvature of a projectile launched with u at theta at the topmost point of its trajectory. So guys, solve this quickly. I can't teach magnetism next. Okay, this is supposed to be for class 11 this series. How can I start teaching magnetism here? Maybe I can conduct some special classes. Okay, I was in fact planning because some of my old students had also requested that they want a revision of magnetism. So yes, maybe I can start magnetism on the app in special classes. Okay, don't worry, I will plan that because. Oh, by the way, I hope now you know that there is News for all you 2020 aspirants that today there was a hearing over a plea in the Supreme Court about getting the JEE 2020 postponed, and the Supreme Court has rejected that plea. I hope you guys are aware of that. So your JEE exams are going to happen in September. JEE Mains is happening in September. Alright, guys, solve this problem, please. You find the radius curvature of a projectile which is launched with some speed u at an angle theta with the horizontal. I mean, these are the standard terms at the topmost point of its trajectory. So you find the radius of curvature when it reaches here. So here, what is the radius of curvature? Find the r here. If it was initially launched with some u at some theta like this. Alright, find this quickly, guys. Can I have an answer? Pawan, are you following? Vineet, Sukhvinesh, I don't know where did you guys go. See, that is why I keep saying that you guys should keep interacting in the chat. That keeps you involved. Otherwise, half the time, I don't know if you are distracted somewhere else. Maybe along with having the lecture screen here, you're looking at some news somewhere else, or maybe doing something else entirely. I would definitely advise you guys, if you are attending a live lecture, then attend it carefully and with a lot of attention. Pay attention to your lectures. Do not get distracted. Make sure your lectures are in full screen modes. Can you recommend channels for physics other than Unacademy who teach in English? Sabrish, I have absolutely no idea. Oh, it's not infinite. Infinite is for straight lines. This is not straight line. This is a curve. So, Sabrish, as I was saying initially also for today, this is the first time I am teaching online. Okay, this is the first time I have any experience of what is happening online. I think before some time I had absolutely no idea about what happens online, who is teaching, where they are teaching. It was only when you guys started asking me who's this, who's that, then I knew, okay, so there is somebody like that who's teaching online, there's somebody like this who's teaching online. I have absolutely no idea about what channels are there online, or in what languages they are teaching, and who are teaching there. I have been teaching during all my duration in offline coachings only, and till 2 months back, I had absolutely no idea about what is happening online. I knew that okay, online Unacademy is conducting classes. I did not even know that Unacademy conducts classes on YouTube. Okay, I honestly didn't even know that. I used to think Unacademy conducts classes on their app only. Wow, theta is 0 and 180. Yes, of course. Okay, so this is very simple, by the way, guys. This is the simplest of them all. When you are here, what is your V? V is u cos theta. Where is your G? So G is already perpendicular. So your alpha is 0. Alpha was the angle of the velocity vector with the horizontal. Alright, alpha was the velocity vector with the horizontal. Alright, so now here you know your alpha is 0 and V is u cos theta. So this should be very, very easy. I know at topmost point, maybe I can write it this with some other color. Alright, so let me write this. At the topmost point, V equals u cos theta, alpha equals 0. Alpha is the horizontal angle of the velocity vector with the horizontal. So now all I need to do is find r, which is from this formula v square over g cos alpha. So that becomes u square cos square theta over g. That is it. This question has been asked, I think, at least 2 times in JEE Mains, if not more. JEE Mains has asked this direct question, this exact question, at least twice. They don't even change the question one bit. We'll just tell you, okay, find the radius of curvature of a projectile at the topmost point of its trajectory. And I think they have asked it at least 2 times, if not 3 times. So you need to know these questions. These are very standard questions which get repeated. Okay, let me know if everybody followed this. I hope you guys followed this. So obviously you will see that this is not a big question. This is not a question that requires a lot of calculation. They can easily ask this in NEET or your AIMS exams also. So Vinesh, I remember that. No, Hitesh. No. Supreme Court rejected the pleas, to my surprise. Okay. Alright. So why don't we practice one more problem and then we'll move on and we'll get started with circular motion. So start this problem. A ball is kicked at an angle of 37 degrees from the ground, which should be the initial velocity of the ball, so that it hits a target which is 30 meters away at a height of 18 meters. You to also find the maximum range of the ball. So here it is. You don't know U, then you don't know R. So you have to find the U and the R. Alright. Okay, in Bihar, lockdown up to 6 September. Okay, sir, do you know about the language Tamil, the oldest language in the world? Yes, I know. I know it is one of the oldest languages in the world. Yes, but unfortunately, I'm not. I don't know Tamil. I can't speak in Tamil. All right. At least let me know that you guys are trying this problem. Just write trying in the chat. Please say in English. What about JEE postponement? What do you mean? See, there was a plea that was entered by people in the Supreme Court of India requesting the Supreme Court to postpone the examination. But as of today, the Supreme Court has rejected that plea. So, Supreme Court has directed that the JEE exam be conducted on the scheduled dates. So, I don't think there is no way around it now. Now that the Supreme Court has ordered to conduct the exam at this date, it will get conducted. Okay. Okay, so are you guys even trying this problem? Because I don't even see trying in the chart. See, if you're not trying, then I'll move ahead. I will only wait if you guys are trying. Because if nobody's trying this problem, then there's no point for me waiting. Let me know, guys. Come on. Okay. So no response means I don't think anyone is trying. So why don't I just solve this quickly? So we can solve it in many ways. So let me just take a one. Let's just use equation of trajectory. So I know what is my equation of trajectory. So equation of trajectory says y equals x tan theta 1 minus x over capital R. Alright. Sir, you keep doing, sir. Meanwhile, I'll be trying. Okay. Okay. So it's very simple. What is this? This is the equation which will relate any the x and the y coordinates of any position. So I know if the particle passes through here, what are the coordinates of this? This coordinates are 18, 30. Alright. So I can, and I also know what my theta is. Theta is 37. So I can substitute all these values. So y equals So the point 18, 30 should satisfy this equation, which means y equals 30, then x equals 18, and tan theta is tan 37, tan 37 is 3 over 4. So I just substituted all these values and let's see what we are getting now. So this I'm getting 10. Okay, so I'm getting 1 minus 18 over r as 40 over 18. Yeah. Okay, that is a little strange that I'm getting my r as negative. Okay, then maybe I misplaced some data. Where could have I gone wrong with the data? It's x by r. This was giving me a negative r, right? Okay, x tan theta. So, or did I take the coordinates wrong? Oh yeah, I took the coordinates opposite. That is why I'm getting this wrong. Uh-oh, 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 uh-oh. So we know theta equals 37 degrees. That is why you should always write it down. And projectile passes through 18, 30, 18. I think I wrote it wrong here. That is where the problem happened. This is 30, 18. Alright, so then what about the JEE 2020 course? Will it be complete before September? Hitesh, what I can do is maybe I can start taking 2 one-shot lessons every week. Okay, I was thinking of that myself. Maybe I can start doing that, and we will try and cover as much syllabus as I can. Alright, so now let's just substitute these values. So what I'll get is 18 equals 30 times tan theta. Alright, now I think we're getting the right answer. So I can see my range as 150 meters. So I got my range as 150 meters. Next, it's very simple. I have to find the initial velocity, right? What should be the initial velocity? Okay, so that is very simple now. I know range is u square sine theta cos theta 2 times u square sine square theta over g. Alright, so let's just substitute the values here. So I know my range is 150 equals u square into 2 into sine theta. Sine of 37 is 3 by 5. Cos of 37 is 4 by 5. And then you have 10. Alright. So let's see what you're getting. Let's cancel this 3 with this. So this is 50. So you're getting u square as 50 times 5 over 4 into 2. Yep, this is what you're getting. So u of course would be 25 root 5 by 2. Alright, so that is your answer. Okay, let me know if you guys follow this. So I got my U and I also got my R. If follow this, let's just get started with circular motion. There is so much that we have to discuss about circular motion also. Alright guys, just quickly let me know if you followed this. There are so many ways in which I could have solved this. I just picked this one. There is no real reason why I use this method. You can use it. You can use any method as long as all your equations are correct. You will get the right answer. Okay, don't worry about it. All right. So why don't we move forward? Because I don't want to waste more time. Okay, I was supposed to discuss this projectile variations also. Okay. So maybe we'll have to take up circular motion tomorrow. Also. Okay. So let's talk about the variations also. So the one variation is if the projectile, instead of being projected from the ground, is being projected from a height. Okay. So from a height, if a projectile is being projected, then again, it doesn't matter. What you do is you always break your initial velocity into y and x components. Okay. So you have your u. You always break this into ux, uy. Now you solve this from here, and you just need to remember that when the projectile lands on the ground, what is the condition? The condition is that the y displacement should be minus h. If this height was h, then the y displacement should be minus h. Why minus? Because you're from the initial point you're coming down by a height h. So for time of flight, you can use the equation minus h equals uyt minus half gt square. You can use this for your time of flight. Once you know the time of flight, then it's very easy. Then you can find your range as ux times time of flight. Similarly, if you had to find the maximum height, then that is also easy. So you already know from here what is the maximum height, plus h would be the maximum height. Alright. H max would become h plus uy square over 2g. This is the maximum height that it goes above the point of projection. It was already at a height of h, that is why this will become your minus maximum height. So that is how you would have solved for all these things. And I'm just telling you, you don't need to remember. You can calculate the answers when you're solving the problem. But one special case, maybe you can memorize the formula. Alright, one special case being horizontal projection from a given height. So if a guy is being projected with this, so obviously you know theta is 0. So theta in this particular case is 0, which implies that uy is 0. So if uy is 0, so you've just dropped it from a height in the y direction. In the y direction, motion looks like motion from rest. Something is dropped and it is just coming down. So for that, you already know some answers. That is why I'm just talking about that. You already knew time of flight was 2h over g, and you will realize that the range will become u times 2h over g. Again, you don't need to memorize these. Just remember the logic, okay? Remember, if something was dropped from a height, then the time it took to come to the ground was 2h over g. Okay, and obviously the range would be time times the x velocity. X velocity is entirely u because theta is 0. So that is how you can solve this. Next, this is a common variation where you talk about a projectile on an inclined plane. Now, how to analyze this one? I can show you all the derivations. Second, let me tell you a small trick. A small trick that can be applied to remember everything here. So, what is that trick? Okay, so why don't we see it here only? So imagine, usually you take your x and y here. The trick that I am going to do is that I am going to select another set of new axes, y dash and x dash. One, okay, why this? I think I would rather have my x dash here and y dash here. Alright, so I'm going to take my y here and x here. Now let's see. Now what I'll do is that I will divide everything into this new y and into this new x. So let's see what I can write. So I can write, this is my uy. Alright. This angle will be theta minus alpha. So when I'm dividing u into this component, uy becomes this. When I divide into this component, this is my ux dash, or I can call it my uy dash. Alright. So these are the two components of x and y that I'm getting. Similarly, what about the accelerations? Accelerations I'm getting like this. So this is my ay dash, or the acceleration in my given y, and this is my ax dash. So in this case, the difference is that I have an acceleration in x direction also. So I can't keep using the equation that I was using till now, which is u cos theta times t. Alright, I have to change that. How? We will see. So now, how do I calculate the time of flight? Now, time of flight is when the particle comes from here to here. So during this entire journey, what is the y displacement? The y displacement is 0. And remember guys, I told you this, that y motion and x motion is independent. So while analyzing x, you can consider y, everything y in y to be 0. Similarly, while analyzing y, you can consider everything in x to be 0. So let's do that. Let's imagine that there is only y motion. So if there is only y motion, you have an initial speed of u sine of theta minus alpha, and there is a retardation of g cos alpha. Let's just completely forget x. Let's not think that there is anything happening in it. Now this is very simple. A point being projected, what is happening in y? Let's see what is happening in y, okay? This guy will go up, attain a maximum height, and then come down. And during the entire journey, it has a retardation of g cos alpha, okay? That is what I will see happening in y. So there will be some h, let's call it h dash, and it will take some time. Now I know this looks pretty much like my motion under gravity. So can I use the same equation? Yes, you can. The only difference is this. Instead of g, you use this. Okay, so your new u becomes u sine theta minus alpha. Your new g becomes g cos alpha. So that is very simple. Now my time of flight is, I can write this as 2u y dash over ay dash. That is it. That is all I'm doing. So you don't need to memorize this also. The time of flight will simply become 2 times new u velocity, y velocity, which is u sine of theta minus alpha, over new y acceleration instead of g. Okay. Similarly, the maximum height. If somebody asks you what is this maximum height, if this was your maximum height h dash, then h dash would also be equal to, h dash would have been equal to u y dash square over 2g dash or ay dash. You would have simply substituted the values here and found the maximum height above the incline. Alright, then there is a matter of finding the range. Now, in finding the range, again there are, let's just stick to one way for now. For finding the range, what you will see is, for I already know the time of flight. How do I get the expression for range? I will know that. I'm not showing you the derivation. You can check it yourself. R equals ux dash t minus half ax dash times t square. Alright, this will be the motion of the equation of motion for x direction now. X direction now has an acceleration. You will see minus ax dash is minus g sine alpha because it is pointing in the negative x direction. So you can substitute the values of ux dash, your time that you calculate from here, your ax dash, and t again here, and you will find this expression. Now I will not recommend for you to memorize this. I don't remember this equation myself, okay? But you should know how to get it in case you're asked a question. And similarly, R max becomes this, and the condition for the range to be maximum is that theta equals pi by 4 over plus alpha by 2. That you can simply find by differentiating this, the above equation, okay? So you don't need to remember the formula, but you should know how you can get your formula. And this is how you will analyze. In case of motion on an inclined plane, you will find a new x-axis, you will find a new y-axis, break all your velocities, accelerations in this new y and x, solve y and assume everything in x to be 0, then solve x while assuming everything in y to be 0, just like normal 1D problems. Alright. Now similarly, if you were going down, If you were going down, then you could have taken the directions the opposite. Okay, so in that case, you could have taken. If you're going down a projectile, then nothing changes except for the fact that your ux becomes negative. Okay, that is about it. But you still break these into these velocities. All right. There is another way that has been shown to you. The other way is that you still break them into these x and y only, and you use the fact that from here to here, you find the x displacement, you find the y displacement. You can use the fact that tan alpha would be y over x. Either you can do that, or you can break your velocities into these x and y's and solve for these x and y's, just like we did in the last slide. So the time of flight would come out like this, the range like this. You can try this on your own, all right, and the maximum range like this. So that is it. Why don't we try one problem? So here you've been told a man is standing on a hilltop, projects a stone horizontally with a speed u as shown in the figure. Define the coordinates of the point where the stone will hit the hill. Okay. So why don't you guys try this problem? Alright, so there is a diagram. So you have to take this as the origin, by the way. So considering this is the origin, find the place, find the coordinates of this guy. You will find the coordinates of this point where this projectile lands. Alright. So man standing on a hilltop projects a stone horizontally with a speed u as shown in the figure. You define the coordinates of the point where the stone will hit the hill. Take the point of projection as the origin. So I hope you guys are trying. Please write trying in the chat so that I know you guys are trying and I can wait for you guys. Alright, so many guys watching, nobody trying, which is strange. Come on guys, you need to be more active than this. You need to participate more, you need to try. And those of you who are watching, please watch the video of the session that I took on Friday, which was how to make the most of your online lectures. Because trust me, if you're not doing that, you're not making the most of these lectures. You're missing out on things. All right. So as I said, since I've been teaching offline, so one of my biggest worries in moving online, of course, there is no option. There was no option these days. All right. So everybody had to teach online. But my biggest worry about teaching online was okay. So I used to feel that the transfer of knowledge, everything that I want to tell my students, will not be as efficient and as effective in an online setup as compared to an offline setup. All right. I know a lot of you guys also would feel the same way. But now I've figured out that that is not the case. We can achieve that kind of efficiency. So please do look at that video that I had taken about how to maximize, make the most of your online lectures. That will help you get that effectiveness of knowledge transfer close to what you get in your offline classes. All right. So do that and please implement everything that I've told you there in your during your online lectures. And trust me, you will start finding that you are learning better online. All right. So since nobody seems to be trying that hard, why don't I try solve this problem? So it has been projected from here with a speed u, that is horizontally. So okay, so I can take any x and any y at any time depending on my convenience. I can take the x and y like this. I can take the x and y like this. So here I just find it more convenient to use my x and y like this. Alright, why? Let's see. Suppose this guy lands over here. So this is x. This is some x and this is some y. What can I say about x and y? I can say that this would be alpha, I think, theta. Okay. So I can say that x is some u times t. If it lands back on the hill in t time, then I can say x equals u times t. Alright. Similarly, what can I say about y? What I can say about y is that y equals half g t square. Because in y motion, in y direction there is free fall. Initial uy was 0. In x there is a motion with constant acceleration. So I can say all that. Alright. I am not taking the negative sign because I have already taken my y to be down. Alright. Otherwise, I would have added minus minus on both sides. Minus y equals minus half gt square. Minus minus would have gotten cancelled. Alright. Now, I know another thing. The other thing that I know is from this triangle. Look at this triangle. Alright, so if you look at this triangle, you can say that tan theta equals y over x. So that is the thing that I'm going to use also. Tan of theta equals y over x. Alright. So from here I can say that y equals x tan theta. Yep. So let's substitute that here. From 1, this, let's call this equation number 1, let's call this equation number 2, let's call this equation number 3, and I can say that from 1 t equals x over u, right? Similarly, from 3 I know this, so let's substitute both these values in equation number 2. I'm going to substitute this here and I'm going to substitute this also here. Let's see what I'll get. I will get x tan theta equals half g into t square, which is x square over u square. So x gets cancelled and I get my x as u square 2u square tan theta over g. Alright, so I got my x coordinate. Now finding the y coordinate is very easy. I can find it from here that y is x tan theta, so y becomes 2u square tan square theta over g. So coordinates of this are x comma minus y. Alright, therefore landing point coordinates are 2u square tan theta over g, comma, minus 2u square tan square theta over g. Alright, these are the final coordinates of the landing point. Alright, so I had another practice problem in mind, but then let's just skip it because we are running out of time. This class was supposed to get over by 5:30, and so I will discuss this kinematics of circular motion in the next class, that is day after tomorrow. Alright, so we'll skip it for now. Alright, so I had some things prepared. Yes, so that is it. I hope this is all that is there about the projectile motion. We are done with the projectile motion completely. We will take up circular motion day after tomorrow, and that is hardly a one-day topic, and then we will also take up relative motion there. So that is it from my side. Please practice all the problems of projectile motion. We are done with everything that is there to know about the projectile. I've told you everything that is there. Alright, so that is it for today. I will take your leave. Now, before I leave you guys, so let me remind you how you can get your Unacademy subscriptions. So once you've installed the Unacademy apps, follow these simple steps. Go to the plus section, select your goal as IIT JEE, click on get subscription button. That is how you can get your subscriptions. Alright. While getting your subscriptions, please don't forget to use my code RDLive. Alright, this code will give you an additional 10% off to an already very affordable subscription pricing. Alright. Now, if you like this video, then please click the like button, which I think guys are already doing. Also, definitely share it with your friends. I mean, we are providing free quality education to every student, so we want you guys to share it with as many people as possible. This should reach as many people as possible. All right. Also, you can press the bell icon to get notifications of all the lectures happening here. PDF form of all the slides that were used in today's lectures would be available for download in the description box by tomorrow. You can come back tomorrow, check that out. You can stay connected with us on the Telegram app using the link shown above. And you can find me on the Telegram app using my user ID, which is @Rohit Dixit. Alright. So before I take your leave, let me remind you one more time, you can get your Unacademy subscriptions using the code RDLIVE. This will give you an additional 10% off. So alright guys, so I'll take your leave here, and why don't you guys practice all your projectile problems and let me know how it is going. Alright. Take care, bye bye. I'll see you.